Start.
Good morning, students. Once again, welcome to Theory of Equations class of MATHS-2A, which are conducted in our webinar classes of our Tri-Society. In today's class, that is Theory of Equations, we are going to learn about equations with real coefficients, occurrence of complex roots in conjugate pairs, and its consequences. And the next topic is transformation of equations and reciprocal equations. And we also solve some of the problems depending on this. Okay, so let us start from the first topic, that is equations with real coefficients, occurrence of complex roots in conjugate pairs, and its consequences. Okay, if a root of a polynomial equation, observe this line, if a root of a polynomial equation with real coefficients is a complex number, that is the root is a complex number, then its conjugate is also a root of that equation. For example, if I take a plus ib is a root where a and b are real. See here, if a and b are real, a plus ib will be a complex number. So, if the equation f of x have a root complex number a plus ib, then a minus ib is also a root of f. Have irrational that is, if a plus root b is a root of b is also a root of x. So here so form the cubic equation with real coefficients, two roots of which are 1, 3 minus.
Hello, madam. Hello. Unable to hear your voice, ma'am. Vijitha, ma'am. Vijitha, ma'am.
Irrational number, that is. Madam, chapana.
Ma'am, unable to hear your voice sometimes in between, ma'am.
Okay, madam. I will check it out. So the another root is 3 minus root of minus 2. Okay. So 3 minus root of minus 2 means it is an irrational root. So since 3 minus root of minus 2 is a root of the given equation, we can consider 3 plus root of minus 2 as also a root. Okay. So hence the required equation will be x minus 1 into x minus of 3 minus root of minus 2 into x minus of 3 plus root of minus 2. So see here x minus 3 plus root of minus 2, and here we have x minus 3 minus root of minus 2. This is in the form of a plus b and a minus b. So a plus b into a minus b is a square minus b square. So by applying the formula, I will get x minus 1 into x minus 3 whole square plus 2 is equal to 0. So again, by opening the bracket, that is by using the formula a minus b whole square, I will get x minus 1 into x square minus 6x plus 11 is equal to 0. So by simplifying, we will get x cube minus 7x square plus 17x minus 11 equal to 0. Okay, children? This is the equation which has the roots as 1, 3 minus root of minus 2 and 3 plus root of minus 2. Now we will check one more example. Solve the equation x power 4 plus 2x cube minus 5x square plus 6x plus 2 is equal to 0, given that 1 plus I is one of its roots. So see here, the polynomial equation's degree is 4. That is, the highest power of the x is 4. So we will call this equation as biquadratic equation. So biquadratic equation. So it has, we know that it has 4 roots. So every biquadratic equation will have 4 real or complex roots. So here they have given one of the root, that is 1 plus I. Equal to 0. So children, how we got this equation? By using the formula x square minus sum of the roots into x plus product of the roots, where one root is 1 plus I and another root is 1 minus I. So since these are the roots and this is the equation with roots 1 plus minus I can call this equation, this quadratic equation, as a factor of our given equation. Since it is a factor, we can divide this equation with the factor so that we will get the remainder as 0 and the remaining roots. So here I am using synthetic division method to solve the problem. Okay. So you know that in synthetic division method, we will consider the quotient of the biquadration. So I am taking directly the quotient, that is 1 plus 2 minus 5, 6 and constant, that is 2. And you are in the previous class you have studied the division in synthetic method by a quadratic polynomial. Okay, so in this case I am taking minus of 2, that is plus 2, sorry, minus of minus 2, that is plus 2, and minus of 2, that is minus 2 here. So remember that method, that is synthetic division method. First of all, we should write zeros in this place. So after writing zeros, we will add them, that is 1 0 0. So adding 1 0 0, I will get 1. Now start multiplication. 2 1 ja 2, and again in the second row again we will substitute 0. Now add this column. 2 plus 2, 4, 4 plus 0, I will get 4. So again 2 4 ja 8, minus 2 into previous term, that is 1, is equal to minus 2. Once again add these terms, minus 5 plus 8 and minus 2, that is 8 minus 7, I will get 1. And next 1 jar 2 and minus 2 into 8, 4, that is minus 8. So again add this one, I will minus 8, that is 0. Once again 2 zeros, 0, minus 2 ones, that is minus 2. And adding I will get 0. So here, this is the place of a reminder. And since x square minus 2x plus 2 is a factor, so by dividing the dividend with the factor, we will get the remainder as 0. Now, frame the quotient, that is, since x power 4th degree equation is divided with quadratic equation, I will get second degree polynomial equation as the quotient. That is 1 into x square plus 4 into x plus 1 equal to 0 as the quotient. So to find out the rest two roots, my work is to solve this quadratic equation. So by using minus b plus or minus under root of b square minus 4ac by 2a, that is the formula used to find out roots. I am finding the roots of this quadratic equation as minus 4 plus or minus 2 root 3 by 2. So by simplification, I will get minus 2 plus or minus root 3. Hence, the roots of the given equation are 1 plus or minus and minus 2 plus or minus root 3. Now one more problem. Solve the equation 3x power 5 minus 4x power 4 minus 42x cube plus 56x square plus 27x minus 36 equal to 0. Given that root 2 plus root 5 is one of its roots. So see clearly here, it is the sum of two irrational numbers. Is it clear? It is the sum of two irrational numbers. So since root 2 plus root 5 is a root, so all possible combinations will be the roots of this equation. So that is so my work is to find out fifth root. Okay. See here, the equation having the roots root 2 plus 5 and root 2 plus root 5 and root 2 minus root 5 is x square minus, applying the formula. Once again remember, x square minus sum of the roots into x plus product of the roots. So x square minus root 2 plus root 5 plus root 2 minus root 5 into x plus product of this roots. By simplification, I will get x square minus 2 root 2x minus 3 equal to 0. In the same way, I will find out the equation whose roots are minus root 2 plus root 5 and minus root 2 minus root 5. So by using the same formula, I will get the equation as x square plus 2 root x minus 3 equal to 0. So this is the equation with two roots, root 2 plus root 5 and root 2 minus root 5. And this is the equation with roots minus root 2 plus root 5 and minus root 2 minus root 5. So we know that these four are the roots of the given polynomial equation. Then multiplying these two equations, I will get the equation whose roots are plus or minus root 2 plus or minus root 5. So by simplifying, I will get x power 4 minus 14x square plus 9 equal to 0. So on dividing this On dividing the given equation with this factor, we get the quotient as 3x minus 4. Okay, student, you can use either synthetic division method or direct division method, which you have learned in your earlier classes. Okay, so from this linear quotient, I will get the root as x equal to 4 by 3. If I equate this one to 0, I will get the value of x as 4 by 3. Therefore, the roots of the given equations are plus or minus root 2, plus or minus root 5, comma 4 by 3. So we got 5 roots. So now let us check by n or the roots of f of x equal to 0, then minus alpha 1 minus alpha 2 and so on minus alpha n are the roots of f of minus x equal to 0. So children, once check this one. What is you mean by transformations of equation? Okay. Okay, they are asking to transform to another equation whose roots are related to first equation. So here the roots of f of minus x are related to the roots of f of x equal to 0, and the relation is negation, that is minus of the previous roots. So then we will get the equation as f of minus, will check and f of x equal to 0, then for any non-zero complex number k, the roots of f of k by x by k is equal to 0 are k into alpha 1, k into 2, so on k into alpha n. Here we are multiplying the roots of f of x equal to 0 with a complex number k, then we will get the required equation whose roots are k alpha 1, k alpha 2 and so on k alpha n as f of x by k. Let's check the next one. If alpha 1, so on alpha n are the roots of f of x equal to 0, then alpha minus alpha 1 minus h, alpha 2 h, so on alpha n minus h are the roots of the equation f of x plus 0. Okay, in the same const minus h, if I h, I will get alpha plus h, alpha 2 plus h, so on alpha n plus h are the roots of equation f of x minus h equal to 0. And the next one is if alpha 1, alpha 2 and so on alpha n are the roots of f of x equal to 0, then suppose that none of the roots is 0. Here no root should be equal to 0. Then 1 by alpha 1, comma 1 by alpha 2, so on 1 by alpha n are the roots of the equation x power n into f of 1 by x equal to 0. This equation is called reciprocal equation, and we will study about this topic in our next concept. Okay. Next formula. If alpha is a root of f of x equal to 0, then alpha square is a root of f of root x equal to 0. So remember this concept and do the rest of the process. So let's take one of the find the roots of this given equation. So in the place of k in the formula, I am taking the value as 3. So given equation, I am considering it as f of x equal to 0. So I will get f of x equal to x cube plus 2x square minus 4x plus 1 equal to 0. We required an equation whose roots are 3 times of the roots of f of x equal to 0. So what will be the problem? The required equation is f of x by 3. Children, remember in the formula we have f of x by k. So in the place of k I am taking 3. So f of x by 3. So substitute x by 3 in the place of x. I will get x by 3 whole cube plus 2 into x by 3 whole square minus 4 into x by 3 plus 1 equal to 0. So by opening the bracket, I will get x cube by 27 plus 2x square by 9 minus 4x by 3 plus 1 equal to 0. Now taking 27 and multiplying the equation, I will get x cube plus 6x square minus 36x plus 27 is equal to 0. So this is the equation which we got by transforming the given equation such that the roots of this new equation is 3 times the roots of the previous equation. Is it clear? Now check one more problem. Find the transformed equation whose roots are negative of the roots of this given equation, given biquadratic equation. Once again, for my convenience, I am considering f of x is equal to the given biquadratic equation. Since biquadratic means I will have 4 real or complex roots. So I am taking that roots as alpha 1, alpha 2, alpha 3 and alpha 4. Okay. Now my work is to find out the equation whose roots are minus alpha 1, comma minus alpha 2, minus alpha 3 and minus alpha 4. That is nothing but f of minus x equal to 0 is the required equation. So substitute x equal to minus x in this equation. I will get minus x to the power of 4 plus 5 into minus x cube plus 11 into minus x plus 3 equal to 0. So by simplifying, I will get the required equation as x power 4 minus 5x cube minus 11x plus 3 equal to 0. Okay. See one more example problem, that is find the polynomial equation whose roots are squares of the roots of the given equation. So remember the last formula. If alpha is the root of f of x, then the equation with roots alpha square is f of root x. Okay. So we will apply that formula in this concept. So my work is to find out the biquadratic equation whose roots are square of this equation's roots. Okay. For my convenience, once again I am taking f of x is equal to x power 4 plus x cube plus 2x square plus x plus 1 equal to 0. Since it is a biquadratic polynomial equation, let alpha 1, alpha 2, alpha 3 and alpha 4 are the roots of the given equation, that is f of x equal to 0. Then we require the equation whose roots are alpha 1 square, comma alpha 2 square, comma alpha 3 square and alpha 4 square. So by our formula, we have that equation has f of root x is equal to 0. So substituting x equal to root x in the equation, I will get root x to the power of 4 plus root x to the power of 3 plus root x whole square plus root x plus 1 equal to 0. So by simplification, I will get x square plus x root x plus 2x plus root x plus 1 equal to 0. I am sending these terms which are not having roots to right side, I will get minus x square, minus 2x and minus 1. And the rest which is left in the LHS is x root x plus root x. So take identify whose roots are the translates of the roots of the given equation by minus 3. Here we are transforming the equation such that the roots are translating by h is equal to 3. So see the problem? Let f of x is equal to x power 5 plus 4x cube minus x square plus 11 equal to 0. So remember the formula we have taken. Since if alpha 1, alpha 2 and so on alpha n are the roots of f of x equal to 0, then alpha 1 minus h, comma alpha 2 minus h, comma so on alpha n minus h are the roots of the given equation f of x plus h equal to 0. So in the place of minus h, the roots are translated to minus 3. So substitute minus h equal to minus 3, I will get the required equation as f of x plus 3 is equal to 0. So the required equation is f of x plus 3 is equal to 0. So substituting x equal to x plus 3, I will get x plus 3 whole to the power of 5 plus 4 into x plus 3 whole cube minus x plus 3 whole square plus 11 equal to 0. And on solving this by applying the formulas, we will get x power 5 plus 15x power 4 plus 94x cube plus 305x square plus 507x plus 353 is equal to 0. So here simplification is somewhat hard here. So this problem can also be solved by using synthetic division method in the below form. See here, the transformed equation can also be obtained by synthetic division method. Okay. Now let us check how we will find out the transformed equation by using synthetic division method. So this will be the easy method. Okay. So let f of x equal to, so first of all consider the given equation as f of x. They have given the value of minus h is equal to 3. So we want the equation of the values of these coefficients. Then these coefficients can be obtained by the following process. See here, this is synthetic coefficients of the 0. See here, don't have the second term. I give the coefficient as 0. So the value will be, the coefficient will be 1, 0, 4, minus. Values with 3 till we get constant of polynomial. So see here, once again plus 0, 1, 3 1 ja 3, 0 plus 3, that is 3, 1 3 ja, 13 ja, 39, minus 1 plus 39, 38. That is 3 into 38, 114. 0 plus 114, that is 114. So 3 into 114, 342. So adding 11 and 342, I will get 353. So this will be the value of a power 5. And once again, see here, again we will divide this quotient with the same value 1 plus 0. Quotient A4. In the same process, divide the given quotient, the quotient which we get by the previous division, divide it till we get a constant polynomial, and it will be the value of A0. So these will be the coefficients of that equation. And if you form a equation, that is 1 into x power 5 plus 15 into x power 4 plus 94 into x cube plus 305 into x square plus 507 into x plus 353, we will get the same equation which we found with the previous method also. So this will be the easy method to find out the transformed equations. Now let us check the next concept, that is reciprocal equation. So what is reciprocal equations? A polynomial, if consider a polynomial f of x of degree n, okay, where n is greater than 0. So this equation is said to be reciprocal polynomial if f of 0 is not equal to 0 and f of x is equal to a naught by f of a naught into x power n into f of 1 by x. So remember here what is a naught here? It is a leading coefficient. Okay, since f of 0 is not equal to 0, so this value will be existing. So f of x is equal to a naught by f of a naught into x power n into f of 1 by x. So we have two types of reciprocal equations. So depending on the values of f of 0, okay, depending on the values of f of 0, we divide the reciprocal equations into two types, that is class 1 and class 2 types. Okay, so see here, a reciprocal polynomial f of x of degree n with leading coefficient a naught is said to be of class 1 or class 2 according to the value of f of 0. If f of 0 is a naught, it will become to a class 1 polynomial equation, and if f of 0 is equal to minus a naught, then it becomes a class 2 equation. Is it clear? To check class 1 and class 2, you should substitute or find out the value of f of 0. Next, if, see here, for an odd degree reciprocal equation, that is if n value is odd of class 1, then minus 1 is a root, and for an odd degree reciprocal equation of class 2, 1 is the root. Okay, and if n is even degree polynomial, okay, if n is even degree, then the reciprocal equation of class 2 will have minus 1 and 1 as the roots. So let us check one more example and solve, which comes under class 1 or class 2 group, and we will check how to solve class 1 or class 2 group problems. So see here, show that 2x cube plus 5x square plus 5x plus 2 equal to 0 is a reciprocal equation of class 1. So how to check whether the given equation is a reciprocal equation or not? And if it is a reciprocal equation, to which class it belongs, we will check in this problem. Okay. So let f of x is equal to 2x cube plus 5x square plus 5x plus 2 equal to 0. Here the leading coefficient, that is the coefficient of x cube, is 2. So a naught is equal to 2. Now substitute 1 by x in the place of x, whether to check it is a reciprocal equation or not. So substituting x equal to 1 by x, what I will get? 2 into 1 by x whole cube plus 5 into 1 by x whole square plus 5 into 1 by x plus 2. So by multiplying I will get 2 by x cube, 5 by x square plus 5 by x plus 2. So by taking x cube as LCM and sending to left side, I will get x cube into f of 1 by x is equal to 2 plus 5x plus 5x square plus 2x cube. But this expression is nothing but f of x. So what I got, f of x is equal to x cube into f of 1 by x. Remember the definition of reciprocal? F of x is equal to a naught by f of 0 into x power n into f of 1 by x. So since f of 0 is equal to a naught, what is f of 0? Substituting x equal to 0, I will get the value as 2, that is a naught. Since f of 0 is equal to a naught, I can consider the given one is of class 1, and since f of x is equal to f of 1 by x into x power 3, so by the concept I can say that it is a reciprocal equation of degree 3 and which belongs to class 1. Now check one more problem. Solve the equation 6x power 4 minus 35x cube plus 62x square minus 35x plus 6 equal to 0. So my work is to solve this equation and find out the 4 roots of this equation. So we observe that the given equation is an even degree equation. Is it clear? Even degree equation. And if I substitute x equal to 1 by x, then I will get f of x is equal to x power 4 into f of 1 by x. So it is a reciprocal equation of class 1. How you are saying it belongs to class 1? If I substitute x equal to 0, that is f of 0, I will get the value as 6, which is nothing but a naught value. So since f of 0 is equal to a naught plus a naught, so the equation belongs to class 1 group. Now see how I am solving this equation. For my convenience, I am dividing the equation with x square. Then what I will get? 6 into x power 4 by x square, that is 6x square minus 35 x cube by x square, that is x, plus 62 x square by x square, that is 1, minus 35 x by x square, that is by x, plus 6 by x square is equal to 0. Now see here, I am taking 6 common from these two terms, that is 6x square plus 6 by x square, that is 6 into x square plus 1 by x square. And again minus 35 common in these two terms, that is minus 35 into x plus 1 by x plus 62 equal to 0. So already you solved the problem in the same model in your previous chapter. So substitute x plus 1 by x is equal to y. Then what I will get? X square plus 1 by x square value, that is a square plus b square value as a plus b whole square minus 2ab. So here x into 1 by x get cancelled. So I will get x plus 1 by x whole square minus 2. But this value is equal to y. So I will get y square minus 2. Then the above equation will reduce us to 6 into y square minus 2 minus 35y plus 62 is equal to 0. So again by multiplication I will get 6y square minus 35y plus 50 is equal to 0. So by using factorization method I can rewrite the equation as 2y minus 5 into 3y minus 10. So by solving that values, I will get the roots of the given quadratic equation as 5 by 2 and 10 by 3. That is the value of y is equal to 5 by 2 and 10 by 3. But what I took the value of y as x plus 1 by x. So the value of x plus 1 by x will be equal to 5 by 2 and x plus 1 by x as 10 by 3. So by taking LCM in the both equations, I will get a quadratic equation as 2x square minus 5x plus 2 equal to 0. And in this next concept, 3x square minus 10x plus 3 equal to 0. So by using formula that is x equal to minus b plus or minus under root of b square minus 4ac by 2a or by factorization, I will solve these two quadratic equations. Then I will get the roots as 2 by 1 by 2 and 3 by 1 by 3. Hence, the roots of the given equation, that is the given reciprocal equation of class 1 are 2 comma 1 by 2 and 3 comma 1 by 3. Okay children, note down today's homework problems. So in your textbook, in your 2A maths textbook, page number 128, exercise 4C, second bit, third and fourth problem. And next, page number 143, exercise 4D, bit 3, third and fourth problem. And page number 144, that is exercise 4D, bit 3, seventh, 1 and 2 problems. So by this, we will complete our theory of equations chapter.
Thank you, ma'am. We shall have partial fractions in tomorrow's class, children.